Welcome everyone to this session number 306 morning, and today I will try to resolve this problem named clone wrap. And okay, let's do it. Okay, this problem is the number 133 and is given the reference of node in a connect undirect graph. Okay, return a deep copy or clone of the graph. Okay, each node in the graph contains a value integer and a list node of its neighbors. And well, basically this is the class of the node, yeah, that contains the val and contains the neighbors of the t's. Test case format. For simplicity, each node's value is the same as a node index, alias index. For example, the first node with the val 1, the second node with the val 2, and so on. Okay. The graph is represented in the test case using an adjacent list. Okay. An adjacent list, a collection of unsorted lists used to represent the finite graph. Each list describes the set of the neighbors in the graph. Given the node will always be first node with the val equal 1. We must return the copy of the given node as a reference to the clone graph. Original graph, you can return the same graph. This looks like clone, the nodes are new, that looks like the same. Okay, and here we have this example. I think that this is a node 1, 2, 3, and 4. Okay, yeah, because it's starting in 1, right? Yeah. In this case, for example, the 1, if I understand, the 1 is connected with 2 and 4. The 2 is connected with the 3, with the 3 and the 1. The node 3 is connected with the 2 and the 4, and the node 4 is connected with 1 and 3. It's here. The first value 1 is neighbors second. Yeah. Here. Okay, and we should return the node. Come on. The node is basically this. Okay, in here I need to return the node, that this node is what is a deep copy? each node value is the same node. For example, the first node with the val 1, the second. For simplicity, each node value is the same node, index 1, index, for example, the first node with the val 1 and the second with the val 2, blah blah blah. The graph is represented in the case using an adjacent list. Okay, the given node will always be a first node with val 1. You must return the copy of the given nodes at reference to clone. I need return the copy of given node as a reference to the clone graph. Let me check the comments because it's a little strange, because basically I need to return a copy. I understand that, but copy of given node as a reference of the clone graph. Yeah. Yeah, I don't catch the what I need to do for with this problem. It will be good also if you. Oh, I forget to share the example here. Mm, I really don't. Okay, I don't catch the what is the problem here. I need a hint. Yeah, it's a little confusing. No, basically the question asks you copy of a connect graph given some nodes in the graph. Basically the question asks you to make a copy of a connect graph. In this case, node. Mm-hmm. Yeah. have this doubt too, because say that you need to return a clone or grab. Return the copy of the given node as a reference to the clone grab. Okay, return the same graph is an error. This looks like a clone. The nodes are running graphs look like the same. Okay, let me check. What happened if I only return node? I think that it should be return false or wrong. Not the value has copied but the reference. Got it. Yeah, got it. I understood. Basically is create all the nodes. Yeah, it's basically only create these nodes, because for example in this case, say that the node 1 node with the value 1 was not copied but a reference to the original 1. Yeah, because it's the same. Yeah, it's basically apply this operation to create. Yeah, for example here, we have the yeah, I understood. Okay, here for example, okay, okay, let's here. Okay, yeah, the idea is that you have this 0 1 2 3, and obviously you start with this node. This node is the node 0 that contains the 2 and 4, and this is a list of neighbors. Yeah, this is another object. The 1 contains the, sorry, no, it's not 0. Here doesn't exist the 0. It's 1 and have a list of the objects with the reference to 2 and 4. And next to is the 2 and is with the objects this. Now the next is 3 with the objects to 4, 2 to 4, 2 and 4, sorry, and the next or the last is the 4, 1 and 3. Yeah, and basically is that if I return the same, or I return, for example, only copy this value or this object, it's wrong because it's a reference. Means that we should yeah, in this case is create the nodes with the values. Okay, we know that we have 1 2 3 4 nodes. Yeah, in this case I can create a hash map. A hash map 4. Yeah, 0 1 2 3, and here is new node with, for example, less 1. Yeah, okay, now the next start is, okay, you start here, the node 2, that is this, What is the value of node 2? No. No, in this case, I think that it's only every node have a value, yeah? For example, okay, node 1 have the value of 1, node 2 have the value of 3 and 4, yeah? And basically is, okay, the first is this, yeah? Add to the list the object of 2 and the object of 4. And that's it. It's only that. Okay, the first is a hash map with the first value is integer, that it's the number, for example 1, 2, 3, or 4, and next to is a node, yeah, map, it's equal new hash map, yeah, and here it's a 4, yeah, integer I it's equal 1, meanwhile it's minor equal, in this moment we don't know what is the number of values, yeah, maybe this is the change for a list, yeah, a list of nodes, list array list, yeah, and here is basically integer I it's equal, no, here is change it and is while here is node okay, here we have the neighbors, let me think, because how can I move to the others? Yeah, here for example we don't know how many nodes we have, right? Yeah, because basically we have only the reference of the first one and have, for example, 2 and 4. My idea is that fill these values here, for example 1, and the values here 2 and 4. Okay, now node, let me check. If I will move to the, for example, to the first that is 2, this 2 is basically this, no, 1, 2, 3, and 4. One moment, please. be back. Sorry. And okay, now yeah, it's moved between reference. But in this case, what is the best way to? Because basically it's only know how many nodes we have here, because it's in increasing 0, it's not 0, 1, 2, 3 and 4, and having this number basically is only you need create for example a list with these nodes and start again with this. The one, sorry, contains this. The 2 contains this. The 3 contains this. Yeah, it's basically this. But the key of this problem is the first is understand, but next to is that if you have, for example, the node 1, this contains of the this reference 2 and 4. You need to go to the 4, and the 4 have the nodes of 2, sorry, the 1 and 3. The 1 has been visited, yeah, now is the 3, okay, the 3, and it's only okay, yeah, the 3 has 2 and 4. The 4 has been processed before. Now is this. The 4. Yeah, it's only have a hash set, I think. A hash set or are connect. In this case, for example, you have a hash set here, and is and obviously have a max, yeah, as a 0 the first time, and next to is start with the first, that is 1, and this one is add here, yeah, and move 2 and 4, and now the next that is at the 2 here and the 4. You go to the first, that is the 2, okay, next to is the 3, sorry, is the 1 and 3. 1 is at here and 2 is at here. 2 has been added before. Now the 3, no, the 3, no, sorry, let me come back, because this could have a cycle in the graph, you know, because this could reference to this and this could reference to this, yeah, okay. With this scene, with this hash set, basically is our scene, but help us to know only how many, not how many, which nodes are has been visited before. Yeah, in this case we start with the 1 is add, yeah, and okay, 2 and 4 are the neighbors, okay, move to this, yeah, now the 2 have the 1 and 3, okay, before is only is add the 2, 1 has been visited before, okay, it's ignored, now the 3 is add, and we go to the 3, now the 3 have 2 and 4, it's add the 3, okay, has been add before, and here is 2 has been checked before, and 4 that it's here. Now we got the 4, and the 4 have 1 and 3. 1 and 3 has been visited. Okay, the size is this. Even it's not necessary this, because with the size of the scene we can know, okay, is this, and basically is create a new list with this element. It's a 4, a simple 4. With the, okay, 4, create the 1, create the 2, create the 3, create the 4, yeah, in a list or in an array, and only it's for each again these elements. But now, okay, This is my idea. I think that it's okay, but I would like to avoid the last operation to for each again all the elements and replace for this. How can I do that? For example, we start here the one. We can create a list of scene and another list, name it news. Yeah, in this case, for example, the one doesn't not exist here. Now, okay, is add normal, and this is create as a new. Even let me change the color here. It's new, and this say we need to denote 2 and 4. In this moment, we know that the 2 and the 4 could add here, yeah, as a news 2 and 4. Okay, now this, for example, 2 and 4. This has been visited before. No, okay, we could move to the 2, and these 2 have the values of 1 and 3. 1 and obviously the 2 is add here. The 1 has been visited before, yeah, and is here. But before this, we can say, okay, news in the index 1. No. Here we can say the news. But no. No, I think that let me create my first approach and next to improve. Yeah, my first approach is basically this is yeah, have a scene height set of the node scene it's equal new hash set, yeah, and next to is I think that it's a DFS node, and this I will move as a global variable. Okay, now we have here. Okay, now in the DFS it's a private void DFS, yeah, and to receive a node, yeah, and next to is ask if no is say that scene dot add node, yeah, and here is a for node n node dot neighbor. What is the name? Neighbors, and here is basically if scene that contains n DFS n and is add, yeah, and with this basically we can get all the values here, yeah, executing this we have our I am thinking that size, yeah, Here, for example, we have the 1, 2, 3, and 4. Mm-hmm. Yeah, it's only for count. And here basically integer n it's equal single size. Yeah, and now we know that exists n elements. Yeah, even we can create here integer elements it's equal new integer node elements it's equal new node of the size n. Yeah, and here we can say that node elements, and here say n it's equal new node, and here is integer I it's equal. Yeah, with this we can fill, and again we can execute another DFS function, but in this case no, it's let me think. I am trying to avoid the double process here, because basically here is again call the node and apply the DFS over the elements, but previously I will do this. Maybe changing this strategy to a hash map where appear the hash map, and say okay, what is the elements that only the elements that appear in this case is the element or the node 1. Yeah, with the 2 and 4. Yeah, and move with the next, and handle this scene for avoid cycle over this. But yeah, having this map next to is basically okay, the 1 what is the values, the 2 and 4, okay, fill, you know. Here let me change this for hash map. This hash map, the first is an integer, next to is a list of integer map, and this map it's equal hash map. Yeah, the DFS, and this DFS receive the number of node that is 1, in this case is here map.put, and it receive the integer index, here is map.put index, if contains but negative contains key index, we can only add here put index new array list. Yeah, it's only for add. Okay, is add this value, and inside them we can, yeah, here here I will fill this map with the values that contains, for example, this with these values basically. For this, yeah, and okay, it's add, and here's it's map.put index, yeah, and next to is map.get or default, yeah, okay, uh, mm, 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 mm. Map get or default, if I create new neighbors it's add, but in this case mm, okay, no, let me only use the values because here is get, add, and dot value. Yeah, with this we can fill all the map with the reference. Basically, we can say that, for example, here, the one is have these neighbors. The 2 contains these neighbors. The 3 contains these neighbors. The 4 contains these neighbors. Yeah. Basically, we are creating this here. I am trying to create here the objects. But I don't know. Oh yeah, we can with another with this, but this is new nodes. Yeah, and have this here a hash set, and here for each of the nodes of the, for example, we are in the index or in the node 1 here. For example, we are in this node. Okay, this node is the 1 and is connected with the 2 and with the, oh sorry, it's not here. Okay, we are in this node that is 1 that contains the 2 and 4, and we can say a map contains this key that is the node or this index, sorry. In this case is no, I don't contain because it's empty. Okay, create this node in here. Yeah, in here is okay, create this register in the map with the empty list, and next to for each these neighbors, and say map.get the index and add, and in this case here I should use the new nodes, yeah. Exists this function, the get or default, in hash set get or default. Now in the hash map I know that exists, but hash set, hash map get or default, no. Hash way, I think no. Hash set is no, I think that no. Okay, in this case, for example, if contains no, but in no. The problem here is the reference. no, this should be hash map because we don't have way to identify what is no here identify what is the node. If you are using reference, basically you yeah, if you are using the value it's easy, but with the reference is more hard. Yeah, and here basically is add, and this is new nodes dot get or default. Yeah, what value and dot val, this is a key. If doesn't exist, create a new node. Yeah, with the end dot val. And no, but it's the same thing. New node, receive the nodes. No, here if the first is create this register. Yeah, here for example, new nodes contains key is not contained, and the key is n.val. Create the register, new nodes dot add n.val, and it's a new node n.val. Yeah, and here is only get. Yeah, and that's it. With this, for example, you receive the index 1, okay, and we should ask the map contains the 1, no, because it's empty. Okay, create this register in this map, and next to is for each all the values in this case all the neighbors, sorry, is 2 and 4 for each, and we should ask the 2 is contained in new nodes, no, because it's empty. Okay, create this new register and attach the reference to the value. In this case, for example, the key is 2 and the new node of the reference is saved in this position. And next to we say, okay, map.get index, in this case the index is 1, add this neighbor. Yeah, and with this, here basically is here it's node.val and .val, that is the reference. In here I should only return map, no, new nodes dot get 1. Yeah, because here was fill meanwhile create or for each the original node. Here see, okay, here this is wrong, is integer and is node. New nodes, is the name, new nodes, new node. Okay, we have another errors. Is put new nodes because it's the hash map. Neighbors is null. think that node is 0. Okay, let me check the constraints. I think that I'm not sure if it's only enough put here a validation where the node is empty or is null, sorry, or here, because if only have one element, no, let me put here if I'm not sure. Node, because node is null. Oh, in this case should be appear as a first validation here. You must return a copy. What? New nodes, get one. Have to put what? Why? Yeah, because here is saying that I am return the same reference. Okay, here. Okay, I will focus on this test. You must return a copy of the all the nodes in the original graph. Okay, to receive the node that the first time is this node with the val. What is the val of the? It's 1. Yeah, even here, node dot val for keep the same reference. And to receive the node in the index 1, node is equal null, no, because what is? Yeah, is this? Yeah, receive this, no, okay, the map contains the index, no, because it's empty. Okay, map dot put the index that is 1 and new array list. We are saying the index 1 contains an empty list. Okay, next to is this node return the neighbors that is 2 and 4, and we will ask new nodes contains the 2, no, okay, add this value with this new reference, and map.get in the index 1 dot add new nodes dot get and dot val, that is this. It's a different reference, and here is for node neighbors since dot contains n. because this is a different reference because was create for the one the copy of the given node as a reference. Weird. Maybe I don't understand the question, but to me it's basically return a new graph, don't using the same reference. For example, this is the correct answer. This is the original graph. This is the new graph, and this looks like a clone. The nodes are new. Graphs looks the same, but in this case it's the same because I return the one, and the one, for example, here receive the node that is one and the index is one. Okay, are null? No. Okay, add the one as a scene. And ask the map contains key. The map contains the key index. Yeah, I think that it should be, for example, the index is one. Yeah, no, it's okay. Let me check the here new nodes. I hope that appear here. Nodes. Oh no, only appear the new nodes. I think that this here parameter is null. Which parameter? I don't understand why still showing this error. You must return a copy of all elements in the node in the original. You must return the copy of elements node. In the original graph. Got it. Yeah. Oh my gosh, it's very noisy question. Yeah. Yeah, I understood. Basically, this is saying that we need return a deep copy, but in the same graph. Means that okay, for example, do you imagine that the original is the black, is in black color. For example, the one is connected with 2 and 4. Okay, 2 and 4. Now the 2 is connected with the 1 and with the 3. Yeah? And the 3 is connected with 2 and 4. And 4 is connected with 1 and 3. Got it? Okay. Now, here's, and this here will say, you must return the copy of all elements node in the original graph. Yeah, do you imagine that here you must return a copy of all the nodes in the original graph? Yeah, for example, in the idea, I think about this problem is, okay, you have these elements, create new ones, then new 1, new 2, new 3, and new 4, and obviously every node contains here their neighbors. Yeah, in this case the 2 and 3. This contains the 1 and no, sorry, the 2 and 4. 1, 3, and this the neighbors are the 2 and 4, and this the neighbors are the 1 and 3. Yeah, and the idea is, okay, you have this one, return the 2, for example, is this, but you should change for this, and the 3 is the same. This 3 is replaced for this 3. Okay, I think that is so confusing. I really don't like this question. Here I can change for node dot neighbors, sorry, no, node, and here it's node dot neighbors, it's equal no, this is the original 1, 2, 3, and 4. Okay, now here is this look like a clone. The nodes are new. For example, this reference is A, the reference to B, C, and D. The nodes are new. Graphs looks the same. Why when I return this is wrong? You must return the copy of the all nodes in the original graph. For example, if the node 1 contains the original graph contains the connection to or the neighbors 2 and 4, we should replace 4 the new 2 and the new 4. Oh, but it's only replace the neighbors or no, because say that return the copy of the given node as a reference to clone graph. Mm, uh-huh. Mm-hmm. Mm, the given nodes will always be the first nodes with one. Uh-huh. You must return the copy of given node as a reference to the clone graph. Means that the first should be the same and the others will replace. For example, here we have this is our original graph in black. Okay, now means that the result should be appear like this. Because this is still same reference to this node that it's new. You must return a copy of the old nodes in the original graph. You must return a copy of all nodes in the original graph. Yeah. Here. Node dot neighbors are equal to new nodes dot get dot neighbors. Yeah, and here return node. Cannot see neighbors because return. Okay, let me remove this case. What? No, I don't understand this question. It's very confused. Yeah. Create a clone. Clone graph. Visit contains create a clone for given node. It's had here. Here clone dot neighbors add bfs. I understand that the one of the idea with this exercise or with this problem is discover the origin of the or discover the real problem, but oh my gosh, I really hate these kind of questions. Return clone. And why my solution doesn't works? Because out of all these nodes are news. Node chocolate visit contains key. Visit and return the new object. This is brilliant. New node list. Okay, let me change this in as an integer. Neighbors. Mm, new node to get. Yes. The node was already visit before. Return the clone from the visit dictionary. New clone, clone node, visit the put node, neighbors. What? Okay, here I know that return a new node. This is completely true because yeah, return clone node. And here is here basically is a new one. But why in my case say that is the same? You must return a copy of the all elements in the original graph. You must return the copy. Mm. Here, no, you have clone errors as now. Mm. Uh, uh, uh. You must return the copy of all mm. Oh my god. Okay. This guy is in has the same dough that to me. what in which moment, or I am return, I am create the new reference but overwrite this reference in one moment, or I am return okay, let me check. This receive the index, the node 1, that is this, and the value is 1. Okay, node is equal index maybe here. If sim that contains index, return. Other case, continue. No. Okay, this receives the node 1 and the index 1. It's null. No, is here. No. Okay, add. Okay, now sim contains the node 1. Map dot contains key 1. No. Okay, create a new register, the 1, and then empty list. Now iterate over the neighbors. The neighbors are 2 and 4. Okay, 2 and 4. And we should ask new nodes contains 2. In this case no, because it's empty. Okay, add this value for this node. In this case is got it. Here, in which moment appear the 1? Let me create here the 1. New nodes, it's node dot val and new node. What? New node? No, it's node. Okay, with this, at the beginning we have the node 1 with the reference 1, whatever. Okay, now here receive the 1. Okay, it's not null, it's not contained here, it's add to the sim. The map doesn't contains the, oh no, yeah, no, doesn't contains, is create. Next to is for each or iterate over the neighbors, return the 2 and the 4. Now we will ask new nodes contains the 2. In this case is not contained. Please create for use in another moments. Yeah, and here is we can put map.get in the index 1. New nodes. I think that in any moment I don't return new nodes dot get 1 dot map here here get neighbors. Yeah, here neighbors, it's equal map.get the index 1 new node.get 1 neighbors new nodes. What? Okay, I will print line let me check what show. Okay, the reference. Here I would like to print a node. The first is node and the next two is this. Okay, are different reference. This is the first point. Now let me check. No, it's not the 4. Is because here, for example, receive the one never fill the neighbors, the node 1, index 1, no, okay, it's add 1. The map contains no because it's empty, it's add. Next to is get the neighbors. We have 2 and 4. The 2 is contained here, no, okay, we can add, and next to is map.get in the index. No, but it's, no, this is wrong. Not new nodes. Here, for example, map.index in the index 1 dot add new nodes. That new node is this. Why is false? Or why is I have this error? And the problem here is that we can, well, we can check the reference in the debugger, but it's very tricky. Receive the one. This is the solution, but receive the node. Okay, the node is null. Return node. Visit contains node. Is not contained. New clone. It's equal new node. Visit put node. And clone. Clone neighbors. Neighbor. The neighbor is 2 and 4. Clone node. What is clone node? Clone node. Dot neighbors. Dot add. Clock grab. Neighbors. Well, let me check another solution because I still don't understand why return false this, or why this is wrong. The question is speak about the copy. The copy is a complete copy of an object. Simple words. Okay, I will continue more late.